Så är det?
Det är ingen
Ja,
storm
absolut.
av folk.
Nej du, det är lite halvfullt faktiskt. Alltså jag är så ängslig för att jag livestreamas ut nu. Att jag säger, jag hoppas han har koll på sina nivåer.
Ja.
Det är
Imorgon
ganska
får vi
fullbokat.
ett
Så
batteri
att
gärna använd alla
Så då är det ytterligare
stolar.
Nu
presentation.
står det och viskar.
For well-known reasons, and in particular, very welcome to this fire safety meet as part of DONSE arrangements, which is a first, and good to see so many faces in the room, and for your awareness here, and everybody else as well, we have also a presence online with a live stream going on here, so both real and virtual attendance today, which is very good to see. So today's agenda for the morning session, the morning seminar, is as displayed here. 2 blocks, one considering Roro and Ropax vessels and one considering fixed battery systems and safety aspects of that. For you in the room, some practical information. Emergency exit is in the rear. There will be the main entrance as you got in here, and also a side door. Questions, when we come to the Q&A session, will be handled in the room with a walking microphone. And that's basically where we are in terms of practical start. And to introduce us to today, we have 3 gentlemen. We have Jonas Bjellenstam, Director General of Swedish Transport Agency. We have Mikael Hägg, Head of Maritime Department at RISE. And we have Ulf Hagström, Chairman of Nordkompass. And these guys represent what we call the triple helix, which is the collaboration between authorities, research, and industry. And starting with you, Jonas, how do you see the value of this collaboration in terms of fire safety and in general as well?
Well, good morning, Martin, and good morning to all of you, also in the virtual context. I would like to take my starting point to your question in the recent years' incidents with fire on RoPax vessels, such as the Felicity Ace or the Euroferry Olympia, showing us that these vessels are quite vulnerable to fire. They don't only carry cargo and crew, but also passengers. And we think this, of course, calls for regulation that is more suitable than the regulation that has been before. And this is why the SOLAS Chapter 2 is open for revision, and we as a regulatory body are participating. And in addition to this fact, we also see the electrification as a major trend in the transport sector, where electrification firstly adds to the vehicles you got on board of the ro-ro vessels, but also in the ship's propulsion in a growing amount. And for these new trends, it's of course essential as a regulatory body for us to gather information and knowledge and modern practice. And we have to do that in cooperation with the stakeholders and the academia. And that's why we, as the Swedish Transport Agency, have an ongoing consultation with the Swedish Ship Owners Association and the Research Institute, RISE, on fire safety. But it is also because it's also the fact that we as a regulatory body in all modes, as a multimodal body, have an approach where we bring in stakeholders' practice and experience and try to work together with academia. Because after all, fact-based decisions, which is important for us, has to lay on fact findings. So those are some inputs to your question, Martin. It's essential for us as a regulatory body to have this cooperation in fire, but also in other areas.
Thank you, Jonas. Mikael, could you give some examples on where this interaction has given RISE particular value?
Yeah, so good morning, everyone. First, the RISE mission is to strive for sustainable growth, and doing so by
Hang on.
supporting...
The microphone is not working.
Start again.
Maybe you like to borrow my phone?
Mycket.
Men det är inget.
Så kan jag sänka Martins.
Yes, that was a big difference. So RISE, the mission for RISE is to strive for sustainable growth, and we are doing that by supporting the Swedish industry. And we are also working very closely to the society in order to meet the new challenges that we have. And in all this, it's very important for us to work very closely to the industry and also to authorities. And when it comes to industry, it's important that we at RISE is really working with the right issues, solving the right problems, having the right expertise. And when it comes to authorities, basically the same, but here it's also important to understand the regulations, the boundaries, the limitation of regulations. One example on triple helix cooperation is the Lashfire project that you will hear more about very soon. And in Lashfire, RISE is coordinating this project, and it's a very broad set of actors where we discuss everything from regulations to innovative technical solutions. So that's a very good example, I think, on working together in a triple helix format. Yeah.
So, thank you, Mikael. Ulf, where do you see Nordkompass in this context, and what would you like to see from research in the future?
The history of Nordkompass is the Nordic Committee of Passenger Ships, Nordkompass, founded that more than 31 years ago. We was establishing in 1991 as a cooperation between the ship owner associations in the Nordic country and major Nordic passenger ship companies. The first meeting was held in Stockholm in January 1991 with representatives from Ship Owners Association and passenger ships companies in Finland, Sweden and the Åland Island present. Representatives from the maritime authorities in Finland and Sweden were invited as guests. At the second meeting, held in Gothenburg 16th of April 1991, also representatives from Denmark and Norway were participating, and Nordic cooperation with reality. Passenger ships on a regular route have been an important way of transport in the Nordic countries since the mid of 19th century. They were a lifeblood on the transport of passengers and goods, not only domestic but also between the countries. For more than a century, Nordic capitals Copenhagen and Oslo, as well as Helsinki and Stockholm, have been connected with passenger ship service. For the longer route, overnight facilities become a cheaper and fast alternative in the latter of the past century. From 1980s, this led to introduction of more cruise concepts where the passenger enjoy the pleasure of sailing and entertainment on board rather than transport across the sea. Never and bigger ships and routes and the passengers have been increased. Many of us remember the Scandinavian Star disaster on 7th of April 1990, where 159 people died as a follow-up dramatic reduction of the number of passengers in the Baltic and Northern Sea areas. Scandinavian Star disaster was a consequence of poor and sloppy operation of the vessel. It became clear that any accident would have serious commercial consequence for all the passenger ships operations in the area. Safe operation of all passenger ships was essential to prevent further accident. Based on motto, safety is not an issue of competition, but for cooperation. Nordkompass was established. We in the ferry business knows that serious accidents in our business market and business is hard to run. Therefore, we try our best to develop a safety as much as possible to prevent that new accidents shall arise. The last year, it had come quite a lot of battery cars on the market, but even other fuels in the transport business. Therefore, Nordkompass, together with RISE and Transportstyrelsen, arranged this seminarium and hope that the delegates shall learn more about safety in this matter. Even the ferries will be developed in the future with different kind of fuels and big fixed installation of batteries. This is something that I hope that RISE will further work with research and development to investigate how we can build and operate these ships in safe way, so we can have a new seminars in the future of this issue. Thanks everybody that have been involved in this seminar, and I will take the opportunity to even give an extra thanks to Martin Karlsson at Stena, who have done a fantastic work with everything in place, put everything in place. Thank you.
Thank you so much for this introduction to today. Gentlemen, please. Then one piece of practical information for those with us on the YouTube stream. If you have questions for the speakers at any point, please use the Menti system as now displayed to register those questions. These questions will not be answered during the session, but instead afterwards via the DSM homepage. And if questions are related to a specific speaker, please note so in your text. Yeah, that was the starting point. Now we get into the real agenda here, and I would like to invite Staffan Brahm, Julia Borgén, and Ola Willstrand, all from RISE. And they will introduce us a little bit to what has been going on and is going on the research area on this topic. So I think, Staffan, you are first out, yeah?
Thank you. Good morning. My name is Staffan Brahm. I work as a human factors expert at RISE, Research Institutes of Sweden. So human factors in this context is about increasing safety on ships through improving the working conditions of the crew, you might say. So most of the work that we do has to do with passenger ferries and fires on passenger ferries. And as many of you know, a fire on one of these ships is a great challenge for the crew. And what saves the day will often be the precision, the quickness of the crew's actions. And the question for us who work with human factors is, so if you want to support the crew in this task, how can we improve the conditions that they work under? How can we create usable fire installations that are fit for the crew's needs? So the work that I will present here is part of the LASH Fire project. As Mikael had mentioned, a 4-year project involving many partners spanning many different issues of fire safety, from technical installations to manual operations. And what we're interested in here is fire management as a process. So how can we support the crew in the best possible manner to make the right decisions, to act quickly, to act precisely in an incident? And in this work, we at RISE, we work very closely together with Norwegian University of Science and Technology, NTNU, and we together with them have been pursuing these issues for 3 years now. Most of our work goes into the issue of information management during a fire incident. So managing information around a fire is a special problem. You have to understand the situation quickly. You have to make the right decisions. You have to collaborate, communicate. So to allow you to do this, what kind of demands do you need to place on the crew's working environment? That's the question for us. In our studies, we've visited many ships at this point. We have often observed that the systems that the crew uses to understand what's going on and how they should act, these systems and interfaces, panels, will often have shortcomings. It can be difficult to produce the right information. Information may be spread out over many different locations on the bridge or in the control room. Information may be hard to understand, communicate to others, and it can often be difficult to see if your actions during a fire incident has the right effects, if you're doing what you need to do. And small problems like these can lead to large delays in a ship fire, and large delays in a fire is a very serious problem. So, to answer these questions, designers from NTNU and RISE have been working to create a digital fire central, a prototype to demonstrate what we can reach by working with user-centered methods, building on the needs of the crew. In this work, we have been working very closely to Stena Line, DFD's crews, trying to understand the practical work that they do, what they need in practical terms in a fire. One of the methods that we've been using is what you can see in the picture here, video-based studies during fire drills to observe how the users, how the crew puts different systems to use, how they interact with each other, how they communicate, and so on. The DFC, the Digital Fire Central, well, this DFC, you can learn more about this if you visit the Lashfire tent at the display here at DSM. But the interface is meant to integrate many types of information that is relevant for the crew into one and the same interface, a large digital interface that you interact with through touch controls. So to bring information together is one core goal. This is meant to increase awareness of the fire situation, what is going on, what has happened before, what is likely to happen next. Of course, when you bring a lot of information together and present it to the user, this may increase the workload of the crew. So this has also been one of the core design goals of this work, to pare down the amount of actions that you need to do what you need to do. We wanted to create a design that is intuitive, easily recognizable by the crew. This is in the ecological design goal of this work. And we have also seen that keeping track of events, logging information and so on, it takes up a lot of resources. Information may get lost in communication. So this is something that we wanted to support as well. So I won't go deep into the functionalities of the DFC during this presentation, but a few core functionalities here are easy access to important controls, the fire alarm, fire doors, dampers, fire pumps, drencher systems, and so on. Information about cargo, separate cargo units based on other research going on in the Lashfire project. Heat and smoke maps to help you judge the development of the fire. And also a timeline where events during the fire are registered, where you can go back and forth and review what has happened, where you can replay communications within the crew, where you can make notes. Okay, so why do we do this work? Well, of course, we know that there are systems out there already, digital interfaces, but the thing is, it's not enough to present new technical solutions. These solutions need to materialize on the ships. They need to get out there, and they need to be well adapted to the needs of the crew. And digital technologies is no guarantee for this. We made a survey last fall where we asked seafarers about their satisfaction with fire safety systems. And one interesting finding was that even on ships where you have a modern digital mimic fire panel, satisfaction was only so-so. So this tells me that digital technology is one part of this, but making it fit for the user, adapted to the user's needs, that's another part. So working with design guidance, how to get good solutions out there, that's also an important part of our work. You can apply user-centered methods no matter what you're designing. It can be an environment, a system, it can be procedures, anything. The drencher room is one example outside of the bridge. If this environment is poorly designed, you may have delays, confusion, even erroneous actions in an incident. So what you need to do here is to understand the user, what the user does, how the user moves, how the user communicates, collaborates, and you can use that information to specify design from global layouts of this environment to the minute details, design of procedures, design of instrumentation, and so on. So this is a way of working that can be applied anywhere. And fire safety is a holistic problem, so it needs to be applied everywhere to support the whole functioning of the fire safety system. So this is where we are now. We understand the problem well. We have interacted with many users, many seafarers throughout the years. So we understand their work. These end users, the people working on the ships, they are engaged. It is easy to find people on the ships who want to contribute with their experience. And we have established methods to work with user-centered design in fire safety. But what we want to do now is to challenge the industry, the owners, to make more room for the user in the design of fire safety. We see that this is rewarding for everybody. The crew gets a better working environment, but this kind of working environment also translates to efficiency, productivity. So our core message here is that if you want to put safety first, then you need to put people first, and that's the needs of the crew, and then you design the ship around them. And that concludes my presentation. We're very eager to chat with you in the Lash Fire tent, so please come visit us, and I'll be happy to answer questions later.
So, hello everyone. My name is Julia Bergen. I also work at RISE, and today I will share some advices with you on how to ensure safer manual firefighting operations by selecting equipment. And this is based on the results from the recently concluded project Safe and Suitable Firefighting. So, when searching for new equipment, one important issue is, of course, to find wheel-marked fire suits at competitive prices. But then, of course, it's also about understanding your needs and to know whether the products you're looking at fulfill those needs. And a question that we've asked ourselves in this project is if you can count on the regulation to fulfill your needs. And my answer is that not necessarily. So there are some things that you need to keep in mind when selecting equipment. But first, I quickly want to show you what the regulations say. So to the left here, you have a piece from the FSS code, and I will not read it out loud, but it basically leaves quite a lot of room for interpretation. And then to the right, we have the Marine Equipment Directive. And for fire suits, this regulation includes 3 different standards. And if you test according to these procedures and reach the specified limits, you can put the wheel mark on the fire suit. So this leaves a little less room for interpretation. And when it comes to these 3 different standards, there is one, EN 469, which is what I would call for regular firefighting, while the other 2 standards, they are for specialized firefighting, very quick operations under specific circumstances. And unless you have specific reasons to use these fire suits, I don't think you should use them. So go for the EN 469 type instead. But it is not just as simple as saying go for the EN 469 certified fire suits. The good news is that this is the same type that is used among land-based rescue service. But you also have to be cautious because this contains 2 different performance levels, which can both be wheel marked. But I will start with the good news, because this is also the frustrating news, Because what this means is that if you find yourself looking at a fire suit that is targeted against the land-based rescue service and doesn't have the wheel mark, chances are that it actually fulfills all the requirements, but is just missing the wheel mark. But if we move on then to the two different performance levels, we have level 1 and level 2, where level 2 is the higher one. And it actually says in the standard that the level 1 is not applicable for protection against risks encountered in fighting fires. So this is more intended for supporting activities. And the differences between the two different standards is regarding heat protection, which is marked in this pictogram with an X. So X2 means that it's level 2 for heat protection. Y is water penetration, and Z is breathability. And within this project, we studied the case of a Roro fire, and for this case and for other types of fires on board a ship, we want to say that level 2 is fit for purpose. And I specifically want to point out the level 2 for water penetration, because what this means is that the level 2 fire suit have this protective membrane. So for instance, Gore-Tex is one of those, and level 1 doesn't. And later we will also speak about battery fires, and something that is usually a concern there is the toxic gas HF. And MSB looked at the likelihood of skin absorbing it, and luckily that seems to be very low. But it has also been showed that a fire suit with a membrane and with an inner layer that actually makes the HF concentration 120 times less. So we have some additional benefits of this water penetration protection of level 2. So as I want to show with this illustration with the labels, both level 1 and level 2 can be wheel marked. So you need to look for that yourself. And it is actually similar with the firefighting boots, that they don't have levels, but instead they have a class which specifies the material, but also a type which specifies the use area, and type 1 is for outdoor firefighting. So here you should stay away from type 1 and instead go for type 2 or type 3. I also have some other recommendations for you. And the first thing is something that we have learned from the rescue service. And this is that in order to be fully protected, you should wear long sleeves and legs under your clothes. And since the fire may break out in the middle of the night, or since some crew members may work in t-shirts, I suggest that you keep spares in the fire station. So if anyone shows up without long sleeves on, they can put something on. And then to also protect the neck and the head, use a flash hood under the helmet. But these are not included in MED, so you will not find wheel-marked ones. So instead go for the ones that is targeted towards the rescue service. Make sure that you have pockets and attachments, for instance for radios and flashlights, so that the smoke divers can use both of their hands. And as I mentioned, it's very good to have waterproof fire suits. Then, of course, also the communication device should be IP rated. And in the FSS code, or SOLAS, we have the axe listed as one piece of firefighting equipment, but there's a whole lot of other things that could be useful as well. So for instance, heat cameras, laminated GA plans, fire plans, pens, timers, bolt cutters, wrenches, and crowbars. And these could be prepared in bags in the fire station. And finally, I also want to advise that you also practice removing contaminated PPE safely. So include this to your fire drills and practice how to remove it without skin contact or inhalation. And the results, they are summarized in this quick guide also, which you can download at this webpage. But I also have some printed versions in the fire safety tent. So please come by and grab one of these and discuss this further. Thank you.
Yes, thank you, Julia and Staffan. So, Ola Willstrand, I'm also working at RISE and working mostly with battery safety research at RISE. Let's see. There we have my project. So I will present 2 different projects with some strange acronym, ETOX and BREN2. Let's see if that works as well. No, sorry. So, ETOX, it's actually 2 projects, one that is finished and one that is ongoing, and it's focused on battery electric vehicles and the toxicity of smoke during fire, and as well as contamination of extinguishing runoff water. And it includes several full-scale vehicle tests that we have done, and some of these tests have been used as input data to computer simulations in BREN2, which is more focused then on the RoRo ship application. BREN2 also focus on gas-powered vehicles with the aim to have some recommendations on tactics and risks during firefighting. So starting with ETOX, this is a summary of the full-scale tests performed. In both, so we have BEV, battery electric vehicle, and ICEV, or ICE vehicle, internal combustion engine vehicle, is a common acronym for conventional cars, diesel or petrol. So in both ETOX and ETOX2, we had the same vehicle model from the same manufacturer, but different powertrains for comparison, but different models and manufacturers for the different projects. Enough on that. So some results. When it comes to heat release rate, which is basically the size of the fire, we can see that both peak and total heat release are or could be affected quite a lot on the fire scenario or on the vehicle model if you have a small car or a large car, but not significantly on the powertrain in this case. In the graph in the top right corner here, we have the heat release curves from the 3 tests in ETOX1, quite similar. And in the bottom, in ETOX2, we had a sprinkler test to see about the contamination of water. And in light blue, if you can see, is where we have activated the sprinkler. So the first graph here is the conventional car. We activate sprinkler at 1 megawatt. Good effect, and when it's turned off, the rest of the car burns. And for the battery electric vehicle, we activated the sprinkler, but then we turned it off because we didn't see any activity from the battery, and then we waited for, we saw 1 or 2 cells going into thermal runaway, and then we activated again. This result does not show that sprinkler will, extinguish battery fire, but it may not have propagated without sprinkler as well. and after sprinkler was activated, it started to burn again. I will come back to about the sprinkler effect on smoke. So here also together with other testing literature, we can see that it's quite same for conventional cars and battery cars regarding to heat release. This is the peak heat release, and the stars here is for the sprinkler test, and that was expected. So when you have sprinkler, you lower the peak heat release. And one conclusion from both these projects actually is that when we had the exact same model but different powertrains, we could see in both, as you see in the table in the middle here, in both projects, the battery electric vehicle had lower total heat release compared to the conventional car. So gas release was the main focus. We can conclude that HF, as Julia mentioned, hydrogen fluoride, represents the largest difference between those powertrains. However, when we compare all the gases produced with health exposure limits, we can see that when you inhale smoke from such fire, there are several gases that are acute toxic, and the HF does not stand out there. So whatever vehicle is burning, you should not breathe in the smoke. But the HF have been in focus due to discussion about skin penetration. But yeah, there have been several studies that show that this have been a bit exaggerated or put too much focus on that. I would say the difference is very small. But this is also an interesting result with the sprinkler, that with sprinkler you also wash out the HF from the smoke. So here is the battery as I show you. When most of the battery burns here at this peak, you see a significant HF peak. This graph show another test with only the battery, and you reach about the same peak heat release rate, but no HF during sprinkler activation. So moving on to the brand 2 projects. As I mentioned, we used data from ETOX to do computer simulations, as you see in the picture. It's representative of a Ruro deck. In this case, the model was 90 meter long, 22 meter wide, 5 meter high. We had two different scenarios. A large multi-car fire, which is basically 3 cars, as you see the 3 red dots here. It was either 3 battery electric vehicles or 3 conventional vehicles, and it started with, you could think of a fuel spill or fast fire scenario and a large fire. And the scenario 2 was a single car fire, starting with a thermal runaway in a single cell. And jumping directly to the conclusions, for this part of the project with simulations, we can see that the ventilation is the biggest single factor in determining the conditions during a vehicle fire. So the differences in smoke content plays a minor role. So exactly what gas concentrations you will have at different points in the Ruro space will mostly be affected by the ventilation conditions and not the type of vehicle. In the simulation, the suppression had a limited impact, but that's because it's quite hard to simulate. We see from testing lash fire that suppression actually have a good effect, also in ETOX 2. However, it will cause a greater mixing of gases, so you could maybe a worse situation with regard to sight and so on if you're doing some manual firefighting at the same time. And the last thing is that with the thermal runaway scenario, that's quite slow compared to this large fuel spill fire, and for quite long time it will be, as long as you stay out of smoke and jet flame, you can be quite close to this kind of fire. And then, as I mentioned, in Brand we also focused on gas-powered vehicles, and we did some experiments with fire-exposed gas tanks. So we had 7 of them, both CNG and hydrogen. And yeah, just showing one result with the hydrogen tank. You see the pan underneath with the external fire, and then we had a sprinkler or water on top of the tank. And with water discharge, you delay the ventilation with 20 minutes. And we also had some scenario where the tank was shielded and the water was only applied to the temperature-controlled safety vent to see if that could cause an explosion of the tank. So it was really worst-case conditions. And the conclusion was that, yeah, we didn't have any explosion, and this TPRD, temperature pressure relief device, then can be cooled based on these tests during firefighting without risk of explosion. We could also conclude that these jet flames have quite low incident heat flux. So compared to a diesel fire, for example, you can be quite close to the fire, but you should stay away from the jet fire, the flames, of course. And then finally, these have led to some recommendations. The important thing here is that we have very different chips, giving different preconditions. So you have small and large. Do you even have a deluge systems? How large fire team do you have, and so on. So that's the preconditions. But then we have put some recommendations into the 4 key stages of fire intervention, or 5 if you include training and fire drills, which is of course very important. There is a quick guide on this as well, as Julia showed for the Safe and Suitable project. In short, let's see. Yeah, in short, the runner, if the runner should of course stay out of smoke, whatever fire. But if it's a small fire, try to extinguish it. I mean, if you can extinguish a small fire, that's good. The deluge or the drencher system is good to activate. Could probably control fire. If it's a large fire and you activate the drencher and it's ongoing for a long time, you should be aware of that. It could be dangerous to enter the space then in a later stage due to gas tanks, for example. However, we support both offensive and defensive tactics. So for the fire team, you will have a time period of at least, I mean, even if the fire starts to grow, you will have 15-20 minutes in general before, for example, battery gets involved in fire. I mean, most battery electric vehicle fire does not start in the battery. So you have another fire, and it will typically take some time, 20 minutes or so, to include the battery. And if you can extinguish the fire early, that's beneficial, since you don't have to take care of a fire exposed or damaged battery that could reignite and so on. And also for gas tanks, as the test showed, that if you try to cool the tanks and so on, you could have some time to fight the fire, and it's first after like 20 minutes or so then if you activate the drencher as well. Then it could be an increased risk of for example, explosion if it's fire exposed. And for the post-treatment, for battery, you should be aware of the risk of reignition, and you should surveil it and cool. For gas tanks, it's important that even if it's in fire-exposed gas tanks, that you still have the gas inside. You should wait. You should not approach that until it has cooled down. But when it has cooled down, you usually regain some strength in the tank, and so you have some safety margin, so you would not expect any explosion in a later stage if it haven't happened during the fire. Yeah, so that's all for me, I think. Thank you.
Thank you very much, Ola, and please be seated for the coming Q&A session. So now, room on stage for Sifis Papageorgiou and Martti Simojoki. That will tell us a little bit about what is going on and has recently happened on the, regulation area and the insurance perspective. Please.
Thank you.
I think it is,
You go first.
from what I see here at least, it is first insurance, right? No, I think you're first. The next slide is...
That's mine. You want to do it?
I
Okay.
don't think I will do such a good job somehow.
Okay, good morning. I will present a kind of a twofold realms. One coming from my background as a car carrier captain, the practical implications, what happens with the heat release rates, how does that look when you have a fire on board, what can be done, what cannot be done, and how the car carriers are different from ro-pax vessels. And on the second part, how insurance industry is actually working together with the operators and the legislators to solve some of these problems, and what you can fairly expect from the insurance industry to give you support. Right, a little bit about myself and the company Alandia that I'm representing. We are in Nordic measures fairly large hull insurer based on Åland Islands between Finland and Sweden, those of you who don't know where Åland is. And in our portfolio we are quite large on car carriers, ro-ro vessels and ro-pax vessels. This is something I cannot resist when it comes to safety, that I usually ask the audience to give some good ideas what safety is, and due to time constraints I go straight to the point. I will come back to the concept of error-positive culture. That is something that we promote, that it is positive with errors. It's not. I will make a clear distinction between a violation, but what is an error positive, and how does that help the industry and the operators to be safer? Our industry was very long time focused on removing errors, and it has not gone that well. We are not getting rid of the errors, and even a well-trained airline pilot makes 5 to 6 mistakes every hour. And that is the reason you have two of them in the cockpit to watch each other and cover for each other. And we, human beings, we make mistakes, and then instead of trying to remove the mistakes, we should create the systems that when the mistake is made, it doesn't lead to a catastrophe. And that may be a bit new approach, and it's part of this device, what is safety, that we, what we mean by safety. And it's not only design, it's also the humans operating the design, and sometimes we might not have the best possible design for the human-machine interface. And I'm sure that most of you know the recent news. I'm not showing any images from the Felicity Ace, since you have all seen them. I don't have any other images. And we are not certain what actually happened. We can speculate on lots of different things and probabilities. But this we know quite well, happened 2 years ago in Florida. And the fire started here in the port, deck 7, port quarter. A second-hand car. The vessel was loading second-hand cars to to West Africa, and the fire broke out already in the port. And on car carrier fires, in 99 out of 100, it's always a second-hand unit. Even though you disconnect the batteries, it's very seldom that it has been a factory new car, which is a good news. So whenever you have a second-hand car, you can expect lots of trouble. Other distinctive feature on this type of vessels, you see the stern ramp that weighs, depending on the design, between 160 tons up to 320 tons, and it takes between 20 to 25 minutes to close it. So if you're in a port and you get a fire, and like in this case you have the fire in the stern, probably the hydraulics won't work, you cannot close it, so the CO2 is useless. At sea you have a better chance, then everything is closed, but then again the low pressure CO2 system, it takes 15 minutes for one single section when you release it. And usually it takes 15 to 20 minutes before you have the crew together and it's safe to release. So there's another problem that, so you don't really want fires on these types of vessels. And it goes rapidly, and this is like a few hours after the ignition, and you can already see that it's going to be a total loss. The steel and the structure, everything's gone. This is inside, and in the accommodation, it's deck number 14, 7 decks above, and here you can see the practical implication of the heat release rate, how much heat it produces. Here's an image. You see how tightly the cars are stowed. This is one of the challenges in this type of vessels, that you don't get access. The modern vessels, they're 230 meters long, 36 wide, on 13 decks, and basically you have a 10 centimeters between cars. And if you have something in the middle, it's physically impossible to do anything here. And if you have a normal conventional powertrain, then you can try to use the CO2 and hope that it bites. And it has also challenges, because if you go there too early, then you have a reignition and you have one more shot of CO2, and if you have engine room fire at the same time, so it's not so much fun. Here you see the how the deck beams look like al dente spaghetti. It's immense heat. This is actually on deck 9, 2 decks above the fire source. Same here, there's already support structures so that it doesn't collapse before the vessel was towed to scrapyard. This is a graphic illustration how the stowage and the problems. I do understand we try to find different challenges, but you can think of trying to get the fire blanket in the middle, and you have 8,000 units on board, so you need lots of blankets, and there's no physical access to do it. So in this vessel type, we really need to find another solution how to solve it. Again, illustrating how the stowage usually looks, and try to. The deck is 165, so when there's a fire, so I wish really good luck if you try to put a blanket anywhere near, or even try to crawl over the cars, and I hope I made my point very clear. Now the insurance part and some statistics. The very good news is that, as you see on the black curve, overall we are getting safer, so the overall claims trend is going down. So we are doing lots of right things in overall operations. However, the fires and explosions are heading the other way. And there we have lots of challenges and problems to be solved in order to get that trend, hopefully, below the red trend. And in this group, we can see that car ro-ro vessels are overrepresented together with passenger vessels. So in this segment, we have still some work to do and to find really good and clever solutions how we actually get the columns down to a more normal levels. Here again, on the other vessels, fire explosions, trend somewhat going down. You see container vessels and car ro-ro going up. So again, to wrap up the car carrier or pure car and truck carrier specific issues, tight stowage, difficult access to individual vehicles. Also, if you're in a port, you try to involve the local firefighters. They have extremely difficult time to orientate where to find, and the other thing is to, again, the physical access. The other thing that we need to, together with the manufacturers, solve is the lack of standards. If you load Volvo, they have their standards. If you load a Mercedes, they have another standard. And then when you have all these different units on board, you need to follow the manufacturer's instructions. And the problem is that, for example, there's no standard for the charge level, state of charge. Is it a state of charge that you can read from the display, or is it something else that is actually on the battery? And there's no standard. In aviation, you're allowed to have a maximum of 30%. And we still have manufacturers that they insist that you need to have 80%. So there's lots of energy in the car, or in the batteries. And now we have the electric buses, and they are having even bigger batteries. So there's issues to be solved. Again, a little bit of the technology. The most used fire suppression system in the large car carriers is the low pressure CO2. The good thing is that it doesn't do anything with the vessel stability. That's one concern, that on a large car carrier you cannot use water. There's two things that, one thing is that you lose the friction. And when you lose the friction, salt water is very slippery. Then you have a cargo shift, and then you definitely have a fire, because when the cars crash, they usually get a fire, and then you have another problem with the stability. So that's sort of out of the equation. Free-flowing system, it's very simple. You open a valve, and then everything's really nice and smooth, but it takes a long time. Like I said, it takes 15 minutes before you have flooded one section. And for intensive car fire, it's a very long time. And in most cases that I have been involved, it's, with few exceptions, it means constructive total loss. As said, it's not very good to prevent reignition. If you enter the space too soon, then you have a reignition, and then you have exhausted your resources. Yeah. Now I see the text is a little bit the CO2 capacity in practice for single zone, because you usually you want to make sure that you can extinguish that zone, and then you're basically done. You need to find your next port to fill your CO2, and if you're between Panama and Australia, it means, if you're in the middle, it means 2 weeks, whatever direction you want to choose. Then we have the low pressure expansion foam used typically in the smaller car carriers, and those systems, they depend on electricity. You need pumps, you need fans, and have been involved in cases that it can be concluded it's not as reliable system. There are technical issues, and it needs lots of maintenance, and when you need it, you don't get it, and then you are really in trouble. Some initiatives to address these problems in this segment, Wallenius Wilhelmsen AFV, Alternative Fueled Vehicle Project. DNV sort of picked up where we left at Wallenius Wilhelmsen, and we are trying to, after pandemic, to get that workshop going again. And there's also a parallel line directly to Lashfire project. Marine insurers, we are quite a few that have background in this specific segment, and we are working together to also try to help and solve and find solutions to and maybe see if you tell more about Fire Safe 1 and 2. And from our perspective, what do we need for safer tomorrow? One thing is transparency, that when it comes to safety and safety issues, that it's shared, because none of us here compete on safety. We compete on other things. We compete on cargo, we compete on turnaround times and so forth. But when it comes to safety, that we might as well share. Then nobody needs to do the same mistake once again. Stakeholder alignment, class, insurers, flag, the manufacturers, operators, so that we could, for example, agree on state of charge, onboard charging issues. There's lots of things that need to be agreed and aligned, that everybody knows how we do this in a safe and a responsible manner. What you can expect from us, and you should expect from us, and which we are happy to provide, all of us insurers, we run massive loss prevention programs addressing these and other problems. So feel free whenever to challenge us and ask us that we have a problem. We have lots of resources that we are not in everything. We are not technical experts, or we don't solve things with statistics, but there are lots of resources, and we can tailor-make them for any customer's needs. Therefore, if not known, that is like the UN of the Nordic marine insurance, based in Oslo, and that's a forum where we insurers don't compete, but we try to find common solutions for everyone. Ajax, the class, statistical analysis, root cause analysis, promotion of professional safety culture, slide 2, where we define the safety, and we also, that's one thing that we have a good technical solutions, but we also need reporting from the crew and the operators, the terminals, that we know what is actually going, that we can detect the risks before they realize into a incident or accident. Collaboration, participation, again, Last Fire project is one of the appropriate examples to lift up today, where we collaborate, the operators, insurers, flag and class, and regulators. This is one of the solutions what we have done, and it's free of charge for our customers to enhance and make the reporting easy. That if you see something, say something, and you are most welcome to ask me more questions whenever. I will not go more deeper in this one. Thank you.
I'm not sure if my presentation is here. I see coffee break being the next. Are you trying to tell me something, Martin?
Fattas.
Which one is yours? It's not that.
Sorry for this technical interruption.
specificity. AFV, the one above. That one, yeah. I'll try to make it fast. So, I'm Seuss Papageorgiou. I'm working for the European Maritime Safety Agency, and I'm going to present briefly the work that we have been doing on mainly, and I will focus on AFVs, so I will not go so much into the details of FireSafe 1 and 2. But I will talk about this guidance document that we recently published, as I think it is quite fresh. So, I will start by saying that this was a team effort. I'm very glad to see a lot of you people here today, people that participated and that contributed to the work. We created in the beginning of 2021 a sort of consultation group, because there was a request from European member states and the European Commission to actually draft guidance or guidelines on this issue. And as you can see here, we had a big participation from administrations, ship operators, research institutions, and other stakeholders. As you can see, yes, also from the ones that are not typically maritime, like, for example, you have here ECG, and they also brought along Volkswagen, and we also had some charging station manufacturers in the group, and this was very, very good help in order to get things in line. The scope that we had, and we had more or less 1 year for this work, was that the guidance should include all ships that carry AFVs. So we're talking about ro-ro passenger ships and ro-ro cargo ships, and PCTCs, of course. We realized very fast that we had to introduce a lot of risk assessment elements that, at the time being, we are not in a position to draft very precise prescriptive requirements on a lot of the issues. So a lot of the issues are still left with the administrations, with the ship operators, but we also see a lot of benefit in this. Then the third point here is that we realized that a lot of it, and I was also very glad that RISE has done a lot of work on this, that there are a lot of operational elements that need to be included in this work. And this is something that typically we as regulators, we have not been so good at least not at an IMO level. We tried to be a bit more specific, and we had very good input for these. We include within the scope all AFVs, so we're not talking about EVs, but also about gas vehicles, and we're looking into the future, even though we don't have so much information. But lastly, the point is that, and this was also mentioned earlier on, that we base the work on available research. So we base the work on the projects of RISE, for example. RISE also made a presentation to the group and tried to bring the group up to speed. But also other projects, the Albero project from Germany, the previous FireSafe 1 and 2 studies. So all of it, we try to put all that knowledge together in order to to produce something. Now, what we produced is this document, which is separated in three parts. It is a general part with basic information in the beginning to start with, saying, okay, you know, these are the requirements of the IMDG code. These are some general characteristics of AFVs, etc. And then we also realized that we had to separate RO packs from the non-RO packs. And we put recommendations in both of these categories. But we have also included two annexes, and especially on one of them I will also say a few more words in the later slides. So what do we say in these guidelines? So both parts 2 and 3, again, I remind you, it's about RO packs and non-RO packs. They're very similar in terms of structure. They start off typically with precaution against ignition. And we say simple things. We're not reinventing the wheel. We say that, for example, it should be easy to identify vehicles. It should be... And that's easier said than done. We are aware of that. There should be, for example, in the conditions of carriage, the IMDG code says that there should be no damaged electrical vehicles being allowed to be on board. We also know this is a very difficult requirement to implement. Nevertheless, we try to put emphasis on things like that. Small electric vehicles, also coming from the IMDG code. Typically electric bikes and well, these electric scooters, they also need to have a dedicated space. Charging, as you can imagine, this was one of the main reasons or one of the main drivers for this work, and we did base a lot of the input that we have in the guidelines on the Albero project, which is this German project that I mentioned before. In principle, what we say is that charging should not be allowed unless there is a quite comprehensive risk assessment, and this is for the RO packs. And this risk assessment is, I mean, within the guidance is 3 pages of considerations that you need to make for the charging stations, and not only for the charging stations, but also in relation to crew training, information to drivers, etc. For the non-RO packs, the recommendation is that it should not be allowed. Then there are some elements on detection. These are not very extensive. The reason is that we also did not have a lot of research available to us at this stage to recommend something in addition for AFVs in relation to conventional, let's say, vehicles. Of course, we do mention that, yes, there is a possibility, for example, for the crews to also carry portable infrared cameras. We do mention gas detectors, that they could be beneficial. And then we reach the fire suppression and extinguishment. Again, here for the fixed system, and I think Marty also made some very good points before, and I would personally align with them. But we still feel that it is a bit too early to go on specific recommendations. We have heard also at IMO there have been, for example, suggestions of having 2 chargers available for vehicle carriers. Nevertheless, we felt that we needed some more meat on the bone from the research point of view to be able to suggest that. But we also have recommendations coming from the project that Julia also presented, and we were also very thankful for that. And then we, as I said before, we have this emergency response procedure that links the work to the annex. And the annex is where, in my opinion, we got to be a bit more creative, because we had a lot of room for operational instructions and guidance. So here you can see all of these points are different diagrams that we have included, ranging from having different alarm levels, confirmation of the fire, what to do, elementary first response, in line with what Ola also presented, saying that, you know, if the runner is there, so a person without wearing PPE, that if that person sees that he or she can extinguish the fire, then they should do so. Fire suppression, there I can say we did not add much. We are based on the fixed system that we have on board. Manual activity, again, we say very clearly that, and we give a very clear preference that the fixed system is the preferred option. But of course, we also recognize that there might be cases where manual activity could be initiated. And then we separate between EVs, gas vehicles, and we have a last diagram of post-extinguishment. These diagrams typically look like that. I'm not expecting you to be able to read that, but there is a lot of information. There are a lot of, I believe, there was a lot of work that was put on each of these diagrams, and well, we are quite happy with the results. In any case, I would like to. Well, EMSA doesn't have a stand, but feel free to come to me, and the guidelines have been published, so you can download them on EMSA's website. And I hope they will be of use and helpful. And to close this presentation, I also want to make a reference to what IMO has decided, or what IMO is doing on this. And one of the reasons that we went for an EU approach was the fact that we could see that IMO or the Fire Protection Working Group in particular, has a very heavy workload, and that this will take a long time to produce something meaningful. And therefore we went for some, and electric vehicles especially are already being transferred in bulk in these ships. So finally, in April 2022, as you can see here, there was an approval of the agenda item. For those of you who are not familiar with IMO procedures, this means from now on, this item, so AFVs on ships, can start being discussed with a view of either developing guidelines or doing some amendments to the regulations. There is a duration of 4 sessions, and this will start, and these are annual sessions. They started in 2023, should be finalized in 2026. There's a question mark. We never know with IMO. Of course, there could be delays. There's a significant backlog also as a post-pandemic effect. And if everything goes well, then we are talking about an entry into force, and if these are amendments, in 2028. And what we were listening, at least from our ship operators in the last few years, was, or already in 2020, that this is already happening. So we're very glad that we have the guidance. And with that, I think I can conclude my presentation. And Martin, the floor is yours. Thank you very much.
Thank you very much. And by that, we would then go into the Q&A session. Do we have a running microphone ready for the... we have. So, any questions in the room here for any of the... We can bring up also the RISE team. Any of the speakers? Also Marty. Where are you, Marty? Any questions for any of the speakers? We have a question here. Hang on for the microphone.
Is not effective in an electrical fire on a car carrier. what are we going to use? Are we just going to abandon ship and let it burn away, or like Felicity, or what is the plan when we have a car carrier with electrical fire? CO2 cannot be used.
Anybody want to comment on that?
Yeah, I don't know. I can comment. I would say, I mean, CO2 could be, of course, effective. I mean, it would prevent spreading from one car to another. If you have a thermal runaway in the battery, of course, you don't have this cooling effect that you sometimes want. But I mean, it's depending on the battery. I mean, it could stop propagate as well by internal passive means. And it's more a matter of fact when you have this inert atmosphere, and if that disappear, I don't know how long time that will take. How closed the compartment is. I mean, how long time will it take before it's not inert anymore? And in that case, maybe it could reignite in that case. But yeah, that was my answer.
Do you have something on that?
If you could repeat the main points, I heard most of it when I was looking for my microphone. So if I understand the question right, what can we do with modern car carriers today when we don't have the new solutions in place? Is that the question?
Yeah, exactly.
Yeah. So, well, the simple answer is that at the moment, the car carriers are not full of electric vehicles. It's part of the cargo. And being the case, you can, with certain manufacturers, you can actually separate the cargo from other. Now we have Volvo, for example. I suppose that's appropriate in Gothenburg to mention Volvo. So you have both XC40 recharge and XC40 conventional. And they are not so happy to separate them in the port. It takes time and it costs money. So they just want to ship the parcel somewhere. That's one of the problems. You don't know which is which, where they are. In the case of Tesla, then you can separate them in one compartment, for example, depending, for example, in the stern. And you know they are there, then you increase your monitoring activities. And as far as they are factory new, there are no documented cases that they have caught fire. So, but that doesn't solve the problem when there's a fire. All the fires so far, they've been in the second-hand units, and in most cases it's also documented they had been damaged. Something hit the undercarriage of the car. And at the moment, in the large car carriers, the best practice is to, if possible, you release the CO2 and then you try to do the boundary cooling. But again, if you are in the North Atlantic or the Northern Pacific in the wrong time of the year, with lots of sea and swell in the upper decks, I would not recommend to open up the fire hose, because then you get a cargo shift, and then you need to abandon even quicker than with a fire. So I don't know if that answers the questions. There's not really much to do.
That's the answer, I think.
And I think this is why we are here. We are trying to find the solutions, and this is a car carrier specific problem, and you guys with the row packs, you're in a better position.
Yeah. I mean, there are some open ends here. There are solutions investigated, for example, in large fire to complement the CO2 system, but we are not really there yet. There is still some work to be done, but for sure there are some open ends in this area.
And like Sifis, you made a reference to the IMO, the China made a proposition with let's use water, seawater. And well, it's cheap and it's easily available, but it creates lots of other problems on a car carrier. In another type of vessel, you can use it. And I think this message is not really getting across that much yet. One thing, I think there's different sprinkler systems, but again, that means a whole new design, and before that's mandatory, and we have most of the world fleet equipped with that. We are all retired long before that. I'm hoping there's also when we work with the DNV, there's a battery specialist that they are looking in what the batteries can do. Can you put the system into the battery that the battery would extinguish itself? That could be one solution, but it's still it's not here, and that's yeah.
Well, I would also say, however, that for example, for the Felicity Ace in particular, I don't think we can jump into conclusions, meaning that we are not sure that the fire started with EVs. Also, and probably we will not find out. And I'm also not sure if the Felicity Ace had a CO2 system, actually. I think
it did. Yeah.
It did. But it's unclear, well, from some information that I have, if it was even activated. So it's, yeah, it is difficult. And I think, but what I'm trying to say is that, and as Marty, you also presented, and I was glad that you didn't present the Felicity Ace, but you know, the incident in 2020, this is a standing issue, but it is also not necessarily depending on the EVs. Of course, there might be some additional issues or some different issues that are present, but we already have an issue.
Thank you, Sifis. Any more questions?
If I may add something, you made a good comment on how tight the compartments are. And when you construct a vessel 230 meters by 36 by 65, it's not hermetically sealed. I can assure you that. You have gas-tight compartments, but you have huge openings. And these openings, when the vessel is moving, it's not tight, and that's why you have extra CO2 and to compensate for that.
Next question, please.
So most of the vehicles today, when we're talking about electrical vehicles, they are using a wireless protocol, right? Is there any way you're working with manufacturers to send out information about the battery so you can sooner detect if there is something wrong with the battery, that you have an increase in temperature, or to sooner understand if there's a problem and then go into these fire safety protocols? Do you understand my question?
I can comment on what we have done with this DNV workshops. Yes, they are working with the battery manufacturers, but then there's also a thing that they are not so happy to open their code. And it depends who you talk to. I don't know, Northvolt, maybe they're happier than someone else, I don't know. But again, there's no uniform standard.
We can mention that this discussion has been up in the EC level, officially, approaching from the marine to the automotive industry with, let's say, a formally positive approach from both ends, but there's a lot of work ahead. Could also mention that in case we have charging, we communicate, depending on what type of charging it is, communicate with the vehicle and get some status information, but then it's wired. But for sure that is the future, because it's the earliest possible way to know the health of a battery is to speak to the car about that. So, very valid question, and for sure on the agenda onward.
But for example, also in our recommendations, we do mention that if the driver has any relevant information about anything going wrong, that they should, as soon as possible, inform the crew. And yeah, we are talking about rope bags. But
More questions?
I think
Do you consider the electrical batteries sort of unstable and thereby represent a higher risk than conventional cars with conventional design, sort of say? And if so, is that sort of self-ignition in the batteries, or what is the problem actually with batteries?
Yeah, I can answer that. So in this ETOX study, for example, we did some literature search and looked at statistics and so on. And based on statistics today, we cannot see a higher risk with electric cars, rather a lower. So compared to the number of cars out there, we see fewer fire incidents. And those fire incidents that do occur, most of them are not related to the battery. I think in Norway, it was a couple of years ago now, but there was, in a 2-year period, they had 45 fires, and it was only one of them that was involving the battery, and even that might not started in the battery. So I mean, battery electric vehicles burn, but most often it's not started in the battery. But then, of course, there is a risk it could start in the battery, and that could have several reasons. It could be manufacturing flaws in the cell manufacturing, causing a short circuit over time. So that risk still occur, but it's, based on statistics, it's not more common with these incidents, at least, compared to conventional cars.
Yeah, because when we check in on a flight, we are asked if we have any power banks in our luggage check-in, so that means, I guess, just there it's a high risk, so.
Yeah, I mean, new technology is often, I mean, followed by caution, and all incidents is big in media and so on. So of course you have to have a high level to start with, and then we can see, based on statistics, we can lower that level over time. But I mean, the risk occur, and if it starts, there is some different challenges than we are used to. How to extinguish it, and risk of reignition and so on. So yeah.
And maybe we can, a battery can not be, or can very hardly be extinguished as a battery, but if you look at the car perspective, if you can suppress and extinguish the car fire, and the only remaining risk object in that is the battery and the risk of reignition, maybe that's a situation that we can live with for some time, if we keep the car under surveillance until we are safely in port. So it's important to distinguish with the battery theory and the car and ship situation. More questions?
Hello, my name is John. Maybe get some rules depending when you're charging this car decks, and put some smaller rooms when all the second-hand cars has to be inside a space that can close, and then inert them just in case of before you transport them overseas. So it's always inerted, and that you can usually take. For example, you have a rule that every new car it's okay, but if it's second-hand car, you have to have this in a special place on the car tariff.
Thank you for the proposal. Yes. Any more questions? We will go very, very soon for coffee, but we will one more in the rear end. List.
Yes, hi. I have two comments regarding gas vehicles. My name is Petter, and I'm from the Regional Fire and Rescue Service. The first is if you're applying extinguished water and cooling the venting, the TPRD, as mentioned before. We ourselves have experienced that we actually ourselves cooled the TPRD and caused an explosion which nearly killed a colleague of mine just seconds away. So that's actually a problem. It's regarded to, of course, more composite tanks, Type 4 tanks, than steel tanks. The other problem with venting and the jet flame from a venting gas tank is, especially when they're close together, is that the jet flame heats the nearby tanks on other cars, and they are not tested for that amount of heating. So that might also lead to a tank explosion. And the other comment I just wanted to make is the explosion from a gas tank makes a pressure wave and an impulse that actually causes brain damage. Regardless, there is no protective gearing that protects you from that. And if it's CNG, that's maybe in the range of 10 to 50 meters, and if it's H2, that's actually the whole enclosed volume that's affected. So that prohibits manual operations in that volume.
Good comments. I mean, these tanks can explode, of course. We have a previous project where we investigate the local fire. So we had a local fire in one end of the tank, and the temperature relief vent in the other side. And in that case, we had an explosion in our research test. So in this test I showed, the focus was really on, okay, can we cool the relief vent such that we get an explosion? And we didn't in these tests, and that was really worst case. And I don't know, I mean, of course there could be incident, I don't know if it was really because of the cooling or if it could be another malfunctioning of the safety vent possibility in certain events, maybe, but this is not the research I'm focusing on. It's actually my colleagues focusing on this. But yeah, you should be aware of the risk, of course. But based on this research, it's still quite low. So it's not that every time you cool the tank, it will explode. So that's not the fact.
Thank you for that. We need now to go for coffee. Any continuous discussions we can hold in the tent in this afternoon. So please exit for coffee and be seated again in 15 minutes, 11:15. Thank you so much.
So, most welcome back in here, out of the sun, but with a well-deserved coffee with you, hopefully. So now we switch subjects to the second subject of this morning seminar, which is fixed batteries, and we welcome on stage Christian Andersson, Senior Chief Engineer from 4C, and Josef Karlsson, Research and Development, Swedish Sea Rescue Service, and they will describe to you a little bit about their respective projects in terms of battery installations on board. And the word is first to Christian.
Thank you. Kommer den upp här nu? Yeah. So, okay. Yes, I'm here to talk a little bit about the conversion of the 4C ferries Aurora, which was done between 2016 and 2018. It was done, that is included the infrastructure in both ports, so that's why the ship I'm talking about is this here, and I don't get the, oops. The text is not coming up as it should. Anyway, this is the ship that we have been rebuilding. This is the way to battery operation. It's quite a long journey. We already in 1992, when the ship was delivered, we have a test catalyst on one of the diesel generators, and in 2006 we installed catalytic cleaning on all the diesel generators, and in 2018 we had the ferry finished with the conversion, and we started the project in 2014 with a discussion: is it possible to rebuild or convert such a big ferry to battery mode? And it was. And in 2016 we signed the contract, and the ship was in operation in battery mode in 2018. Main technical considerations was power infrastructure in the port, the lifetime and environmental impact from the batteries, of course, was very important for us. We would have to maintain a high-frequency sailing schedule. We could not tell our customers we should stay in port longer to charge the ferry, so that was very important for us. And also it was important for us to purchase green electricity from the suppliers, and turnkey delivery was very important. And well, with the knowledge we have today, that was really important, because it's been a rocky ride, I can tell you, but very interesting. This is the original layout of the ship, and it was a diesel electric ship with 4 generators and 4 thrusters in each end. And this is the original design. So in that case, we decided to keep the engine room intact, and the deck number 7 was at that time nothing on. So we decided to add the converters and the batteries and charging transformers on deck number 7, which we think is a great solution when we look back. So the whole diesel electric propulsion system is still intact. We have 640 batteries on board, and they are situated, as I said, on deck number 7, and the total storage capacity is 4.1 megawatt hours. this is the batteries that we use. It's lithium-ion batteries, and the lifespan is about 5 years, and or that's what the supplier have guaranteed. But we can see what we have done so far with our state of health test, that we will at least, or we expect to use them at least 6 years. And this is how it's the construction of the cells. It's a cell carrier with cooling water. It's water-cooled batteries. Here you have the cell, the chemical cell, and you have a heat spreader, so you get the heat from when you're running current into the cells. The heat will come out to the water, and then you have a compression foam, because when you run so much current in so many cycles as we charge, it's a heavy, and it causes heat, and also the battery expands, but it won't expand further than to the compression foam. And then you have a thermal barrier here to, if in case you would have a thermal runaway in one single cell, the thermal barrier will protect the heat to expand to the next cell. And yeah, that's how it looks inside one of the containers. Each container is about 1 megawatt hours you can store. And this is, we have Shift Clean Energy battery system. And this is how it's done. It's each module have 24 cells. And you have, in case you have a thermal runaway in a single cell, the flammable gases will expand through the release valve and out to this duct behind the racks. And inside or behind the racks, this ventilation, this one of the speakers before said much about the ventilation is very important. And you have an exhaust fan that is continuous running in case there is a thermal runaway and flammable gases or explosive gases is produced. They will then be released out to the atmosphere. And yeah, as I said, excessive heat, fire with toxic gases, and risk of explosion. So that's all the risks that we have identified with the installation. So how did we think in the fire velocity, and how did we build it? So we have, together with the flag states and class, many different things here installed, but we have the gas detectors in each container, so they are always measuring. And also we have indication of outside the containers for the ventilation fans. You're not allowed to go inside the container if it's not indicating the air farm. And these indicators are also connected with the integrated automation system, so you will get an alarm if one of the fans stops. Inside the containers, we have, of course, fire. We have multi-detectors, smoke and heat, fire alarm, sirens. We have an aerosol system that can extinguish a fire inside the container if we have a short in the power cables or something is something else. But of course, it cannot handle a thermal runaway. In case we have a thermal runaway, there's no other option than to release the sprinkler and fill the whole container with water. But that is, then you lose all, it's salt water, so you will lose all the batteries in that container. And also, of course, the ship's fire alarm system is have detection, and we have in ECR and in both bridge, it's a double end and ferry, so you have workstations on both the bridges. The outside, we have different options. We have a drencher shell protection in case we have a fire in the accommodation and that will spread. The heat will go inside the containers. So that's a normal case. You start always the shell protection outside the containers and protect them from the heat. And you can also then connect separately the inside drencher, but it's not always connected. It's like a safe thing, so you don't make any mistake. You have to think a little bit more before you connect the hose and start the inside sprinkler. So there's the BMS system is very complicated. It measures the cell voltage and the temperature on each individual cell, and the set point for the cooling water is 21 degrees. We have done quite a lot of experimental with the cooling water set point, because the internal resistance in the cells varies a lot, and we found out that the best set point is 21 degrees during the first couple of months when we were running. The automation system gives alarms at 45, 65 and 75 degrees, and at 75 degrees you have automatic shutdown as well. We have this aerosol system will release automatically at 300 degrees, but it can be released also from the bridges manually or from the control room. And that. Emergency stop philosophy is also something that we have discussed a lot during the risk assessment that we have in the early stage of the planning of the system, and there's a lot of emergency stops. We have inside the containers, locally at the strings. You can do it from the control room, ECR, and you also can do it from the integrated automation system. Things can change really quickly with this amount of enclosed energy, so we think this is very important. Also, with a high voltage shore connection robot, we can emergency stop it very quickly on the ECR or in the bridge. It takes 45 seconds to connect the robot. It's fully automated, the shore connection. And here we also have some emergency stop that's on the charging station on board and on the charging robot tower on the shore side. We have 4 towers or 4 robots. And so it's redundant. We can charge from any berth we berth to. One other thing that is also very important is the quality of the cooling water. As I said before, it's water-cooled modules, and here we have a pre-filter of the deionized water, and then you have a UV filter, and also you have to keep control of the conductivity of the water, and that's being measured all the time, and it should not be above 100 microsiemens. So, and it's been adjusted with this mineral filter here. So. And this is how we charge. Normally we charge 10.7 megawatts, 10.4 kilovolts for an average of 7.5 minutes. It's equal to about 1 megawatt hours. And the depth of the charge is 27%. So when the state of charge is 39% when we arrive normally, and then we charge up to 66%, and then we depart. So this is the ideal depth of the charge for this type of battery to keep them running for at least 5 years. And we also did a lot of elaboration with that in the beginning to find the ideal DOD for this installation. We have 2 high voltage cables, each 300 amps, connected to the ship, and we have a lot of charging cycles. It's normally 48 times for 24 hours. Our crossing is 20 minutes, and we charge every time we come to port. Theoretically, we can run 3 trips without charging, but that won't be good for the batteries because we will go very low on the state of charge, and we would then go very high to recharge them, so it's not so good. We charge with 2.4 C, and we can also charge in hybrid mode. So that means we can push the button on the bridge. The captain can decide to, if he's running low, he can just push the hybrid button, and 1, 2, or 3 generators will start depending on his decision, and they will start to charge the batteries. We can also run the ship in diesel mode. That means we disconnect the whole DC link on the ship, but normally that's a safe to port operation and it's not used. But sometimes we need to do hybrid crossings due to maybe delays in the port or passing traffic. That means that we can't go the shortest crossing. So, but yeah, that's how we do. And it can be done. We were sailing in 93% in battery mode last year. It was a very big success, and we reduced our emissions with 12,000 tons of CO2. So it's quite an impressive installation. It took the ship was out of operation for 8 weeks for the conversion, and because as we added a lot of weight on top of the ship on deck number 7, we had to do a lot of reinforcement from deck number 4 up to deck number 7. And then we had to pull 11 kilometers of cables, different types of cables, but that was all done during operation. Most of the installations were done during operation. It was only the steel reinforcement and the installation of the special DC-DC converters and other equipment that was done during dry docking for 8 weeks. And then also we did the infrastructure from the grid owner to from about 3 kilometers from the port. So we did the cabling from the high voltage stations in Helsingborg and Helsingør down to the port and build the charging towers. So that's that's it. I think I'm ready. Okay.
Was I? Oh, there. My name is Joseph Carlson, and I represent the Swedish Sea Rescue Society with our vision of 0 lives lost in Swedish waters, and to develop the first zero-emission rescue boat prototype. Secondly, I represent the project ELIN, which is funded by the Swedish Energy Agency, the Postcode Lottery, and these project partners. Our project aim is to contribute to faster development of smaller commercial vessels, to electrical power, and to enable zero-emission solutions. We're doing this by building a small 8-meter prototype with the present standards for ships, because that's what's available for small boats at the moment. We will therefore not be able to comply with all the rules as they are stated, but hopefully as many to still be able to be safe enough in our application. When we started in 2020 with our wish list, we landed in a solution that was too attractive not to take, namely combining hydrofoils with the battery power. Besides the much lower greenhouse gas emissions for the same transport work made, the reasons for this choice are many, but I'll try to describe a few of them. Batteries are a good way to cut greenhouse gas emissions over the life cycle, but the energy density of current battery technology is much lower than, for example, diesel fuels, which means that we have to work around it, operationally or technically. The results from our research on our mission database gave us enough basis to set a range goal of 35 nautical miles with a few characteristics over there. With these 35 nautical miles, we achieve 95% of our emissions, combining foils and batteries as a technical solution, while the last 5% we say may be possible to work around. Why not all the emissions then? Well, we have to look at this in the shadow and value of the greenhouse gas reductions, both cutting total energy usage and using a more climate-friendly source of energy. This is also our first try with something totally new, and we don't know what more we will discover on the way. But we want and we need to look around this corner. Additionally, with hydrofoils, we aim to improve our working environment, hoping this will give us a more comfortable ride, which can reduce the risk of strain or injury and take us faster towards the scene, even in turbulent waters, compared with an equally heavy boat. And with batteries, we reduce service hours, which also is very important for us. But yes, with foils, we add a complexity of new technology, but for the right benefit. There. This is an illustration of the boat as it is, and it's a work in progress. The rib will weigh in on around 2,500 kilos, whereas the batteries and driveline will make up for 950 kilos, which is about 38% of the total weight. We're able to achieve this by using state-of-the-art battery technology combined with the most compact and lightweight submersible motors available from Spark. Not to forget to mention the composite technology from Aston Harald. You can see the battery compartments fore and aft of the steering pulpit to concentrate the main weight over the hydrofoils from Monterey. The current battery modules from Micropower have a capacity of a very shy 99% kilowatt hours, and gives us, with the current setup, charging time of 3.5 hours to 20 to 30%. The top speed is 35 knots, and the hydrofoils are retractable to enable us to work even in shallow waters. So now that we are in our last year in this project, we want to hand over a working boat prototype with heavily reduced greenhouse gas emissions, which will be the preferred choice for our volunteers. And to the industry, we want to hand over our findings that we have and are still discovering in the project. Look at your operational profile. It will give you good insights of your actual needs, which is a cornerstone in the climate and the change we need to achieve to reduce climate impact. For us, this means that foils, submersible motors, and batteries may be a match made in heaven. The next step is to use these insights and experiences, which we aim to hand over in the form of a list of requests for clarifications and discussion points for further development of the applicable regulations. These questions should be useful for both regulatory bodies as well as researchers in aspect of battery safety and electrical propulsion in smaller workboats. We welcome you to join us in our mission to reduce greenhouse gas emissions. We want to share our results and data. We're open for suggestions. And furthermore, this boat is to become a demonstrator where there are possibilities to try other setups. Thank you.
Thank you very much, Josef and Christian. And we welcome back Ola Billstrand, who will tell us a little bit about recent research on this topic.
Yes. The mic is not on. Yeah? Yeah, now it's on. Let's see. So, yeah, back on stage. So if there's any new in the room, so I'm a researcher at RISE, focusing on battery safety, you could say. Again, I will present two different projects. First, this holistic safe battery concept that we developed in a project called Lätta elfartyg, or Electric Light, as well as Lionfire 2, focusing on extinguishing system for fixed battery installations. This Electric Light project, so I will just summarize very short. This was a concept study. I will focus then on the safe battery concept. But very short, this was a concept study to look at a fully electric vessel between Gothenburg and Fredrikshamn. And it was a battery installation of 60 megawatt hours. So it's more than 10 times the 4C, for example. Some conclusions from the project is that it's a commercial alternative. It will be more expensive to build, but it will be more cheaper to operate. And in total cost, it will be comparable. It will also be weight neutral because you can remove a lot of other equipment from current engine compartments and so on. And you can also see where you have the batteries in the bottom of the ship. Yeah, that's all. So my part, or the team in the project working with the battery safety, we drafted what we call a battery fire safety concept that should be applicable to any ship, not only this ship. And we try to look at not so much on the battery design or the battery system as such, but more than, okay, you can have any battery system in your battery room. What safety precautions do you have to do, or what you need to have a good safety concept, you can say. So this is the part. Of course, you have to, the first thing here, you have to test your battery that you will install, and for example, thermal runaway integrity, or look at thermal runaway propagation in case of an incident. We choose to define something that we call casualty unit. I will come back to that. But based on that, we should also, that you could say is your design safety level. So based on this unit, you could also design your ventilation system and explosion integrity and so on. And the structural integrity also include location of the battery compartment, backup power, compartmentalization, redundancy of the battery rooms, ventilation, detection, of course, fire suppression, and testing. And the casualty unit, we wanted to put a level, okay, this you should be able to handle. You cannot, I mean, you cannot say that you should be able to handle 60 megawatt hour of batteries in thermal runaway. That's not realistic. It's like saying that you should be able to handle all the diesel oil burning at the same time. So some kind of unit of failure that you should be able to handle. And we didn't want to talk about battery module, for example, because that's quite vague defined. And different manufacturers could mean different things. So we just made this up, call it a casualty unit. But so what it is, it's based on thermal runaway propagation tests, but it's not only that, but it's also it could be the largest units of parallel connected cells, or the largest unit without external short circuit protection, or the unit where you tested propagation, whichever greatest. So these are the things that we think is important. So you don't only design for a single cell because you tested propagation on single cell level. And then when you know what this unit is, it could be like a module, for example. Then you design your battery space, ventilation, and explosion integrity based on this. And ventilation, we think is very important because the main risk here is the flammable gases that could be produced. And we tried to talk about 3 different levels. So basic ventilation here is what you typically have in an engine compartment. It's only for the battery room in case you have, which is quite common, the batteries encapsulated with a separate ventilation, as in the 4C example, for example. Otherwise, if you have an open rack system where the gases will be spread in the room, you should at least have the preventive, let's see. Yeah, good. So the preventive ventilation should be able to handle gases from one single cell. That should be the minimum for the batteries. And then the casualty ventilation, as we call it, you should be able to increase the capacity in case of detection of a failure. Then you should be able to increase ventilation capacity to be able to handle this unit then, whatever it is. I should also mention that on the ventilation, we also have a new ongoing project focusing more on the ventilation concept. It's also interesting to connect it to suppression systems, because some suppression systems you need to turn off the ventilation. It's also important to connect it to post-fire strategies, as we have seen in the incident in Norway, for example, the ferry there, where you have these flammable gases, and when you ventilate it with fresh air, you could have an explosion. And also how to deal with damaged batteries when you have them in the bottom of the ship, for example. You should have procedures how to remove them safely. It could take very long time otherwise. When it comes to detection, smoke detection is good as a basis for the room. We think that also that you should have some early thermal runaway detection closer to the batteries. It could be gas detection. It should be it should be redundant from the battery management system. So you have, because the BMS could of course also detect thermal runaway, but you should have redundant systems. And it's also important with feedback in case of an event. You should not go in there, but you should be able to know what is happening. When it comes to fire suppression, we chose to define two different systems with two different performance objectives. It could be fulfilled with one system, but in case you have, for example, a saltwater sprinkler system as a last resort, that only fulfills the total compartment fire suppression. And then you should have also an initial response fire suppression that could be activated safely without damaging the batteries and to assist prevention of thermal runaway propagation. But then it's also good with the last resort system to prevent fire spread to and from the battery rooms, for example. So that was some of the main parts of the safety concept. The salt water was quite heavily discussed in this project for good reasons. So you can see this picture here is the original design, and we said, okay, in case of grounding, you can have salt water inside the battery room. We instead increased marginal from intrusion from the bottom, but we also said there could be other ways in case of collision through ventilation systems and so on. So we need to look at the possibility of seawater intrusion. We did some tests on cell level with batteries in salt water, and the conclusion was that when it comes to electrolysis gases, because when you put battery in salt water, the salt water will act as a load, and you produce hydrogen and oxygen through electrolysis. And with this size of battery installation, the conclusion was that this is manageable by the normal ventilation. It's not a rapid process. And then we have the risk of short circuit and thermal runaway, but that will require higher voltage than cell level. So it's very unlikely to happen on cell level. So you need some 100 of volts. And then we rely on external short circuit protection on module level as an important safety measure. So moving on to the next project, Lionfire 2, focusing on fire suppression systems. This project focused, the main focus of the project was really to develop a test method, because there is no test method for this today, for fire suppression of battery or battery systems. We did some study visits for sea, for example, and this picture I think is from Elvi in Gothenburg. Based on, and also literature search and so on. And then we tried to make a test setup with both live module and dummy modules. We tested in in our fire hall for repeatability, and then we did some real tests with fire suppression in the end. The problem with batteries is that there is quite large variance between different batteries, even if it's lithium-ion. So it depends a lot on which battery you test. We tested 2 different modules. So we had a test set up here with the red module as the live module, and then dummy modules surrounding it. And it was 2 different chemistries, the same amount of energy, but different formats and size of cells. And we could conclude that the repeatability was good between these 2 tests with the same type of module. This is the heat release rate. But you could also see that it's a large difference between the different type of battery modules here, with much lower heat release rate for the red curve here. Good enough. We moved on to suppression. No, this is still pre-test or without fire suppression. With the red module on fire, we could conclude that all the orange surfaces here exceeded 200 degrees Celsius in this free burning test. DNV has in their guidelines 85 degrees Celsius as criteria inside a dummy module when you test. And then it's a matter of heat transfer, of course, from surface to inside. We try to have a worst case scenario or test setup with no other passive heat no passive barriers for heat transfer between the modules. So it was really to evaluate the fire suppression systems. And then we come to the actual tests. It's quite hard to summarize, but I will make a try. So there's a lot of tests here. You don't have to care about the table here, but it's some tests with different systems. So it's sprinkler, it's mist, it's some different additives, FM100 and AVD. It's a gaseous system. And the main conclusion, okay, so this was not optimally designed for the battery rack, so it was standard sprinkler position that you would have in the ceiling or roof for all these systems to be able to compare. And the main conclusion was really that the design of the fire suppression system and how it access the seat of the fire, or how, if you could, sometimes you talk about in-rack systems or more optimally designed systems for the battery system. That matter much more than the difference between different agents, so to say. And these tables here shows the average temperatures of the let's see, M3 module, which you don't see because it's behind the small picture in the right top corner, but that's just above the live battery module. And it's average temperatures for the first 5 minutes, the first 15 minutes, and the first 40 minutes to see on short-term cooling and long-term cooling. And the lower one here is for the dummy modules on each side. And here you have some variance. But if I should say something about this, you could say that the gaseous system, as well as the mist system, as at least for this module, these three here, performed well. And the reason here is that they were good at extinguishing flames also at the back of the rack. So they had good volume protection or access to the flames. And that was the main fire spread between modules here. It was the flames. So when talking about suppressing battery fires, you often talk about cooling, but that's important when it's tightly packed and for propagation, for example, inside a module. But if you have some airspace between the modules, then the flames will have probably much greater influence. And that could also be seen in this test, the AVD, because the AVD, you get some insulation as a heat barrier, but that was only applied on the front of the module in this case, because you had the sprinkler here. So you don't got access to the back of the module. And then you had the flames on the back, transferring heat to that module, and also insulating the front actually increased temperature of that dummy module. So it's more a matter of design than different agents. That's one conclusion, I would say. So there is no test method to evaluate the performance of batteries fire suppression systems today. This is a proposal, but I think it's need further development. The test indicates that traditional design fire suppression system, meaning in the ceiling, the standard sprinkler, in its own will not be enough to control thermal runaways. So you have to have more specifically designed systems or other passive means to stop propagation. But all systems had some positive impact, but more work has to be done. And as I said in the beginning, they were not optimally designed, so they could perform better if better designed. Yeah, that's all for me.
Thank you, Ola. And in the good spirit of recycling of speakers, we re-welcome CFIS on stage for the regulatory aspect of
Thank you very much, Martin.
this topic.
This was very interesting. Thank you, Ola. Keep on learning on these. For those of you who were not here before, my name is Ilis Papageorgiou. I'm a senior project officer at EMSA. Before starting, I think I also have to make a small disclaimer. I'm not the main person at EMSA working on this file, so most of the work has been done by my good colleague or ex-colleague Ricardo Batista. There it goes. So I will talk a bit about a project that EMSA was, or that EMSA commissioned, and it was performed by DNV in 2019 and 2020 on this subject. And this was mainly, well, a desk study on the different options and also a gap analysis on the regulatory side. And we thought that at that point in time, this was an important thing to have. As you can see, one interesting topic about, or one interesting element of this study is that it tries to address this issue holistically, meaning, for example, talking about all sorts of different configurations, but all sorts of different battery technologies and options you may have, also talking about the future, talking about future projects. So I would say it's a good reference to sort of start the work. Another thing that I think it is also interesting, it gives some statistics, such as these ones, about the increase of ships with batteries installed. This is 2020, and I find it very interesting. I thought about updating it, but I also thought it's very interesting to point out what a big increase we have had of these sort of ships. So here, as you can see, in 2021, it was foreseen in 2020 that there would be 334 ships. Well, actually, today it was from the same database, so the same kind of reporting and the same sources. They reported 429 ships. So you can see the huge difference here, and I'm not trying to point out that, oh, they, they didn't predict properly, but exactly the fact that we have had such a huge increase, and this increase is far beyond what even the experts had been expecting. Ship types of these ships, as you can clearly see, we are mainly talking about ferries, as these have the best potential also for reasons mentioned before. Regular patterns, so easy to keep, like especially when it comes to the charging profile, short routes. This again is reported from 2020, although the numbers are not correct as of today. The trend is very similar, so we are talking mainly about ferries, offshore supply ships, and what is here categorized as other. This is not meant to be readable, but it is also meant to point out that we have a lot of different sources when it comes to regulatory. So we definitely see that it is not a common approach for the time being. There are no IMO rules on this. There are a lot of different good class rules going to similar directions. There are some administrations that have been quite proactive, and typically the administrations that have to deal with these ships, obviously. But what we also see is the need to somehow try to do something to homogenize all this information and not have a lot of different standards. For this reason, what is currently going on is that there was a request by member states, and in particular Sweden, to do something about this on a European level. And what we decided at EMSA together with the Commission to do is something very similar to what we did with AFVs. So we have a very similar concept, creating a consultation group, working more or less a year, and trying to produce some guidance based on information that is available. Already, I think the colleagues are well. They have managed to create a group. It is still open for anyone who wants to participate. So this is an open call, and I can extend that call. It says first get together in June. There is a virtual meeting. Well, I know some of you will try to, I've been told, find a quiet spot this afternoon to participate. Good luck with that. Sorry. So it is today, but in any case, it is the introductory meeting. I think the big bulk of the work will start in September. Today, as I understand it, there will mainly talk about the scope and what are the main directions that this work should take. In general, just as some concluding remarks, we have seen a lot of different issues with batteries, or not necessarily issues. I mean, as we saw in the previous presentations, what we see are rather regulatory gaps and issues that perhaps have not been addressed properly from a regulatory point of view, but we also do see some knowledge gaps. And nevertheless, as I said, we have, as of today, more than 400 ships sailing. So there's definitely a need to, obviously, and in this forums, do something about fire safety and try to look at it in a holistic manner. We'll have to do to introduce risk analysis elements, as we did with the AFV document. how this is integrated into ship design. I think there are obviously a lot of questions. We might need to talk about robustness. For example, I'm not sure if I've heard recently that in some cases, especially of smaller ships, there has been issues with lower IP ratings of batteries, access, ventilation. I think there are really a lot of elements that we will try to tackle. I don't know, as with the AFVs, if this will be successful, meaning that again, the attempt will be to focus on existing research and then try to update it in the future as information becomes available. So that is it. Main message is that at some point in 2023 there should be some sort of guidance coming from EMSA on this subject as well. And if you want to participate, please let me know and I will bring you in contact. Thank you. It's a Q&A.
You can stay.
Okay.
Thank you so much. That concludes the presentations on this topic, and I welcome back the presenters on stage because we will now run a Q&A session. And do we have a moving microphone? And any questions from the audience on this topic?
This is the question for the Aurora ship from Helsingborg. And you mentioned that you thought it was beneficial putting all the batteries on deck 7. But I didn't catch what was the biggest advantage doing that.
Well, in case of an emergency, that would be a very good position because all the released gases and heat would just be able to expand above. If it was enclosed into the engine room, there's another kind of discussion on how to handle it. So for us, we think it's a great option. And also they are about 500 millimeters above deck number 7 on beams. So we are able to cool down with shield protection, of course, and also with normal fire hoses on the deck number 6. So that's the main reason for us. And also it was a lack of space because we did really want to keep the diesel generators and the diesel electric system intact if possible. In the beginning there was discussions to remove 2 generators, but we are happy to keep them alive.
Hello, Johan Jennestig from Swedish Coast Guard. To RISE, you made very comprehensive tests on battery fires. Have you also had tests with liquid electrolyte as well as the newer fixed ones?
A good question. No, we haven't studied solid-state batteries in testing, at least not public research. But that will be interesting future field, and yeah, many talk about it as the savior or the safe future. It's important to distinguish between. You talk about solid-state batteries, but then you could talk about both solid polymer, which still is flammable and burnable, and solid ceramic electrolyte, which is non-burnable. So there's a big difference there. And then you of course have the lithium metal that you want to have to increase capacity, and that's why you want the solid state such that you can use the lithium metal, which is hard to use with liquid electrolyte, and that could also cause some other problems. So that's a future research field, definitely. Yeah.
Okay, thank you for very enlightening and interesting presentations. My question is directed to 4C. I'm not sure if you're aware of the case of Utterröningen, the fire on the battery room. And one of the contributing factors was failed O-rings on the cooling piping. And I understand that you also have liquid-cooled batteries. Are your piping connections in the battery cells, are they also, so to speak, secured with O-rings? And in that case, how do you monitor or maintain the health of the O-rings?
Yeah, the system is pressurized, and we always keep control of the pressure in the system. So if the pressure goes down just very, very little, we know there's a problem. But so far, we didn't have. We have quick couplings for the connections on the modules, on the single modules, and we inspect them regularly. But we would see immediately if we have a leak that the pressure would go down. So far, to be honest, we've been running since 2018, and we had one leak, and that was the first month. So it's been going very good.
More questions? Yes.
Thank you. My name is Sofia Furstenberg-Stott, and I have a question for Sifis. You mentioned, you show this graph of the acceleration of the number of battery-driven ships being ordered every year, like over 400 every year now. And you mentioned that OSVs is maybe the biggest kind of sector, together with ferries. Would you be able to say anything about the similarities or differences in the fire risks of batteries depending on the different ship types, and if the learnings are transferable or very distinct?
Right. I would say it really depends on the type of battery that is installed, and of course between OSVs and passenger ferries there is also a different kind of operation. So you also have, or you could have, different operational elements. But so I would see those as being the big differences. I mean, especially for passenger ferries, I think one of the main reasons, as I said, is that they have such fixed services, and usually, I mean, most of the batteries are installed on short routes. So with OSVs, what we see is a much, that they have to be quite more flexible depending on the actual service of each ship, and that can bring some differences. But then when it comes to the safety precautions, I would say that they're rather than system specific, and that can make a difference. Yeah. Thank you.
Any more? Maybe one more question we have time for. If no further questions, thank you so much to the speakers, and we go to the next step. Ulf Hagström, could you please join me here? Thank you so much. Finns ingen? Jaha, men då tar vi denna. Or we take this one. So, we have established something we call Nordkompass Fire Safety Award, and this is the first time for that to be given to a person. And according to Nordkompass, let's say, principles, it is a Scandinavian language, so just now I will switch to Swedish and continue in Swedish.
Så kan vi be John Borgman från Forsy komma upp på scen. Yes.
Okej. Årets Nordkompass brandsäkerhetspris tilldelas John Borgman på Forsy Aurora av Helsingborg för sitt arbete med att möta upp nya brandrisker ombord i form av faran med litiumjonbatterier. John har utvecklat utrustning för att under en personbil kyla ett termiskt rusande batteri. Utrustningen har testats och förevisats av MSB och DBI. Och är nu på plats som del i beredskapen på huvuddäck ombord på Aurora av Helsingborg.
Så. Varsågod. Och vinnaren behöver vi ju inte visa, han står ju här. Så. Vi går till nästa slide. Detta är alltså föremålet som belönas härmed. Kan ses borta på testområdet sen efter lunch. Så John, vill du bara nämna varför du kom på idén och jobba med detta?
Jag fick en förfrågan av min chef då, Christian Andersson, som sa till mig, kan du inte, jag har fått en inbjudan här från er, de har MSB och RISE Sandö Kramfors då, som heter ERIA, Early Response Innovation Arena. De hade en förfrågan om hur man skulle kunna förbättra släckningen av bilbränder och batteribränder. Och då tänkte jag väl okej, jag får hitta på någonting vad vi har i material ombord. Så jag tog ett stålrör och gjorde först med dysor och så hade jag en idé att det skulle vara hjul på så att man kunde lätt föra in den under bilen. Jag sagt och gjorde den. Och vi skickade bilder och gjorde tester på bildäck och så tyckte de att det var bra så de hämtade den med en lastbil, körde upp den till Kramfors och Sandö för att vi skulle testa den. Men under tiden så tänkte jag till att jag var inte riktigt nöjd själv så jag sa jag får nog beställa lite material. Så tänkte jag hur hög är en Tesla? 15 cm. Då måste den här vara lägre än det för att man ska få bästa effekt. Så att jag gjorde den i fyrkantsprofil i aluminium för att den ska vara lätt. Jag satte 3 munstycken och gjorde den delbar. Nu har jag förbättrat den ännu mer. Jag har gjort den med en fläns för det var lite grann hastigt och lustigt. Jag skulle åka tåg upp och jag hade inte plats att ta med den på tåget så jag fick göra den delbar med flänsförband för att få med den på tåget upp. Men när jag väl kom upp där så var det inga brandmän tillräckligt. Det var 4 stycken så jag fick vara med och testa också. Så jag har verkligen testat all utrustning själv som brandman uppe på Sandö. Så att jag fick se hur det fungerar. Det jag tycker är viktigt med en sån här utrustning det är givetvis att den ska vara lätt och det är den ju i aluminium. Den ska vara underhållsfri. Man ska inte behöva färska av den eller någonting utan det är hål och sen är det liksom en paraplyformad munstycke. Så att egentligen är ett hål och så ett paraply och det är liksom inga saltkristaller eller någonting som kan fastna på den. Så det är egentligen ingenting som behöver färskas av. Det är ingenting som måste justeras in. Det är inga ben som ska fällas ut och sånt där. För kommer man in i ett rökfyllt område så vill man inte missa någonting för man ser ju ingenting när man är där inne. Utan man vill bara in, sätta på med ventilen, öppna på vatten och så ska man få den till att fungera. Så ska man lämna den och då ska den stå stadigt kvar. Hjulen är gjorda så att när man väl släpper ner den så släpper hjulen upp så då står den på fötterna. Så de är bara aktiva när man lyfter den lite grann och rullar den. Ja. Det var väl kortfattat vad jag skulle säga. Jag tackar så mycket.
John kommer ju finnas tillgänglig borta på testplatsen här sen för att visa och så, sin grej.
Ja, tackar.
Då tackar vi er och then we switch back to English and the final remarks for this event. Thank you so much for attending either on the web stream or here in this hall. There will now be lunch served where the coffee previously was served, and I encourage you after lunch to attend what will happen on the harbor area, where we have a tent and demonstration and so on of different fire safety related devices touching the aspects we have been discussing today. All the speakers will be available there for continuous discussion on topics we have handled here or other topics. So strongly welcome there after lunch. Thank you so much.